Okay, this is what we were doing. Okay, we decided that PFRAD is a nice class, and but it doesn't meet some of our needs. We like to take a backup of the current array whenever needed, and later when we need, we can restore it. And this is one example of PFRAD backup class. It is initialized like a regular PFRAD. I construct the object, and in a loop I add the elements one by one, and then I print the elements one by one, right? And then do what? Yeah, I print the elements one by one. Then I take the backup, I empty the array, and I print the get number used is going to be 0. Then I restore it and I print them, and like that, I'm going to see everything on the screen. Okay, this is what we were doing, and for that we designed this new class, PFRAD backup. It is derived from PFRAD class, right? It is derived from PFRAD class, and it has constructors, copy constructors, and the constructor that specifies the capacity. I think I would do this an explicit constructor, right? Because you don't want to convert integers to arrays, right? So I did that, and I have my backup and restore. These are our, I mean, we are implementing this function just for these two functions, backup and restore. The rest, okay, these three constructors, this assignment operator, and the destructor, they are all done because we have to. Why? Because if we don't have them, our class will misbehave. It will do memory leaks. It will do crashes, dangling references, and etc. And it will not be properly initialized. Okay, so these are my data members, and they are both private. Remember, we made this thing protected. Okay, so I started implementing this by ourselves, but I'm going to follow the book now. The book says that for the no parameter constructor, just initialize it with capacity. Okay, so it looks like it is very different than what we were doing. It says that my capacity will be the same as the capacity of the array. How did I implement this? I think I initialized to this null PTR, right? Last time I did that. Okay. You guys are the sun directly goes into your eyes. Okay. Fine now. If you like it, keep it that way, otherwise. Okay, so it always keeps some space for the backup space. Remember, the book's version is not fully dynamic. When I keep adding more stuff, it says that I am out of space, and it doesn't add anything afterwards. So it says that why not allocate everything at the beginning, and whenever I need to take a backup, the backup is simply copying of stuff from the real store to the backup store. So it is get capacity at the beginning, get capacity at the beginning, and this is copy construction. Copy construction is okay. So first do this copy construction thing with the base class, with my old object. Okay. Well, I wouldn't call it this old object, but okay, it is the other one, right? So remember what's happening here? This is PFRAD backup class, but this is PFRAD. Remember, this what's happening is a relationship in here, there, right? Okay, is a relationship. That's why I can send it to the base classes constructor, and then I have this get capacity. new double, and I copy this stuff one by one. Okay, I copy this stuff one by one. Okay, so this is how I take the backup. Remember with this backup, the book says that my design is always keep the backup space initialized and nicely allocated. So I am just putting the numbers one by one. What did this one do? You guys understand what it's doing? It says that I am going to call this operator index one by one. So it could have, instead of doing this, I could have, what I can do is just, okay, it is backup, right? So tell me what is the alternative way of writing this? Did you find the result? Did you find the answer? You made a discussion, right? I'm talking to you, yeah. No. So what is your guess?
I don't know.
What is the question?
I don't know.
You're not listening? Okay.
We can pass an argument.
So it is always to give me that kind of answer, that those are my answers, okay? Tell me what should I write here? Instead of operator, did everybody understand what's going on here? I am saying that I am calling operator index on myself. An alternative way of writing this would have been maybe, I don't mean this, but I can do this. I can do this, right? And parentheses. If I can find no, not that one. It's so stupid. It just puts the thing. What is this? Okay, I am trying to get the curly braces. No, the other one. Other one is here. Okay, I found it. Okay, I could have done this, right? No, I don't want to do this because this one and line 31 and line 32 is exactly the same thing. No, I don't want to do that. Third way of doing this, third way of achieving this. Okay, hint for you. So I need to modify this line.
Which one? The current one?
What?
The current one?
Yeah, line 33. Modify this line so that it becomes exactly the same as line 31 or line 32. Okay, one more hint for you. This is PFRAD's private data members. This is PFRAD backups private data members. Okay, what should I write here? Come on, let's just write this. Okay, this is how you take the backup. You might say that, well, I mean, A is the base class's data member. Yeah, that's true, but remember, I made this protected. I have direct access to this A capacity unused. Okay, I can do that. So which one do you like best? In terms of performance, line 33 is the best because you are not calling any operators, okay, that we have implemented. You are directly accessing the elements of A. Well, you might say that there is an index, but this index operator is going to be used anyways. Remember how this index operator is overloaded? It uses this in the index operator underneath, okay? But this relies on the fact that I have made my private data protected data in the base class. If I didn't have it, if I had it private, then I had to use either this one or this one. Okay, line 31 would have been the most readable, and software engineering wise, object-oriented programming philosophy wise, the best solution. Okay, good. Any questions? Okay, let's go to the restore. Restore is like this. Well, this is smart, right? Not very efficient, but smart. Just empty array first, then add element of bi one by one until I get use b. This will automatically adjust everything, including use values, right? Okay. Good. Assignment operator, first call the base classes assignment operator, PFRAD operator assignment. This will this will handle everything, all the details of the base classes details, like the doing the assignment of this. Where is my, okay, maybe I should close this one and close this one so that it doesn't confuse us. Okay, it will handle all the deep copying of this double A, okay, double pointer A, capacity and used. Once these are all handled, I have to handle the rest. What is the rest? Rest says that if my capacity is not the same as the right side capacity, that means what? Right side and left side myself, we are using different capacity values, so I need to deallocate my space and get some new space, and after that do the copying from the right side to myself. Okay. And finally my destructor is here. Okay, destructor just deletes this one. Remember the destructor of the PFRAD. Where is my destructor of PFRAD? Yeah, it is just this. This one deletes A, and this one deletes B. And remember again, no calling of destructors explicitly, no explicit calls of destructors. Destructors are called by the compiler automatically. Okay, the compiler produces code to call the destructors. You don't call them. It is not you don't have to call them. It is not, okay, you don't need to call them. It is you don't call them. No calling of destructors under no circumstances. Okay, destructors will be called automatically. Whenever a PFRAD backup object dies, okay, its destructor will be called, and that destructor in turn will call the destructor of the PFRAD. Okay, which one do you think will be executed first? Let's go to this code. See this one, where is my, yeah. I made a PFRAD backup object, line 31, and then I did all that stuff. When I come to line 77, this PFRAD backup will die, right? When it dies, its destructor will be called, but PFRAD is at the same time is a PFRAD backup object. A is at the same time a PFRAD object. This destructor will be called too. So two destructor will be called, okay? Which one do you think we called before the other? PFRAD backup destructor or the PFRAD destructor? If I have a hierarchy like this, where is my PFRAD hierarchy? As always, whenever I need it, yeah, but doesn't matter, yeah, okay, good. If I have a hierarchy like this, if I am killing a object of B, which destructor will be called first? Let's go to A destructor will be called first. Why?
Because it's smaller one. It's B is general. B contains.
No, A is more general. A has the, remember A doesn't know that B is deriving from it, right?
I thought
B is more complicated, maybe B is more specific, but again, okay, continue.
I thought B is driven by C and A is driven by C.
A is the base class, B is derived from A.
Then if you delete B, it's the first thing will happen is C.
Yeah, the first thing, okay, yeah, exactly like that. Let's look at how the construction works, okay? If I am constructing a C object, okay, if I am constructing a C object, remember how the constructor is implemented? Constructor says that, okay, this is my constructor. First make a base object, right? After the base object is done, I am going to do this myself, okay? And this is the order of the constructor calling. Let's go to that one. If I am making an object of C, okay, of course I am calling the constructor of C first. I call the constructor of C, but before C starts executing, it calls the constructor of B like this. See, before this one starts executing, line 21, it calls the constructor of the base class, okay? And then B's constructor calls the constructor of the class A. A's constructor will execute first, it will finish. Then B's constructor will execute, it will finish. Then C's constructor. This is how the object is formed, right? When you make a C object, there is a B in it and there is an A in it, right? So before building this A, you cannot build this B. Before building this B, you cannot build C. That's why you need to build A first, then B, then C. Okay? A PFRAD backup without a PFRAD doesn't make any sense. That's why A has to be constructed first, then B, then C. Okay? So this is how the construction works. How about the destruction? When the destructor is called, okay, when the destructor is called, you cannot destroy, you cannot delete A first because B and C depends on it. B uses some stuff from A. Remember how PFRAD backup works? A doesn't know that B is derived on A. B doesn't know that C is derived on B, right? Okay? So that's why you cannot destroy this first, then this, then this. You have to destroy C first, the green part, then you have to destroy B, then you have to destroy A. Okay? Just the opposite of the construction order of these objects. Destruction order is just the opposite. In the construction, A is built first, then B, then C. In the destruction, C is destructed first, then B, then A. Yes?
And do we have to call constructors of A and B in the constructor of C?
I think we answered this 2 or 3 times. Does anybody know the answer? Do you have to call the constructors of A and B from the constructor of C, or do we have to call the constructor of A from the constructor of B? That's the question, right? Do we have to?
Yes.
No. Well, no. Yes and no. Well, the syntax-wise, you don't have to, but tradition-wise, yes, you should. If you don't call the base classes constructors, what happens? If I don't call, okay, if I erase this one, I am just erasing it. What happens?
No problem.
It will behave exactly the same. Why? Because the default behavior is if you don't call the base class as constructor, the no parameter constructor of the base class will be called automatically. Okay. For this case, there will be no problem. But if you don't call it here, you are in trouble, right? Because that one specifies the capacity of the base class object, right? Because it has this one. Or the same thing as it's here. If you don't call it, you are in very serious trouble. So the answer is syntax-wise you don't have to, but as a rule of thumb, always call the base classes constructor. In this case, you didn't have to call. Okay, it will work exactly the same, but you should call it. In this case, you didn't have to call. If you don't call it, you are in trouble. Your software will not work. Okay. Yes.
You said that A doesn't know B and C right class.
Yeah.
My question.
Base classes, this PFRAD, okay, this PFRAD class, if you make Control F PFRAD backup, you will not see it at all, right?
I will ask some a question. Is there any way to count right class from a main class?
Yeah, I mean, you mean inside this code?
Yes.
Inside this inside the base class?
Yes.
No, because as I said before, the code for vector is written like 20 years ago, right? And I am driving it today. I am driving a new class from vector today. How do they know that I am going to drive a new class like 20 years later, right? But the opposite is true because I can always count my ancestors, right? I can say that who am I derived from that, and who is that derived from that. Okay, so derived classes always know their parents, but other ones they don't know their children. Okay, good. By the way, I mean this derivation stuff is not magic. It's just very simple, very similar to composition. You keep some objects, some instances of your objects in your class, and all the functions come automatically, but you don't have to. Maybe you can copy, paste them, and repeat them one by one. And the source that you are copying the code is not going to change. So I mean, you can do everything yourself without using any compilers. Without using any compilers features. Only there is a relationship. Compiler doesn't know about there is a relationship in that case if your compiler doesn't support inheritance. But for that one, we have C's, nice C's, typecasting. I can typecast anything to anything. So the compiler will not help me in terms of enforcing the ISA relationships. But well, in C, we don't need any help, right? We are good enough by ourselves. We don't need any help from the compiler. We don't need any help from anybody. But if we are in trouble, well, you don't need any help. Doesn't help, right? So you will handle everything yourself. Object-oriented programming languages, they will help you enforce object-oriented programming rules. If you like to enforce those rules yourselves, then you are fine. Okay? But most people can't do that. It is difficult, especially if you work with a team. So we use these compilers. Okay, so PFRAD, again, it's an exercise for you to write this PFRAD backup class, okay, PFRAD backup class, without assuming that there is a capacity limit. Remember, we have a capacity limit. Add element. I like to erase these lines. Remember how we did it? If I am above the capacity, then get some new space 2 times the capacity. Okay, get some new space, delete the old values, and make this assignment and continue. Do that, and of course your PFRAD backup is going to change. Okay, I always do that. I ask people to just look at this UML diagram. PFRAD, there is a derivation here, okay? PFRAD backup, we already know that. But how about this? What does it say? There is both is a relationship and has a relationship between these two classes. How can I design such a hierarchy? Yes.
It inherits each other. There.
No, you cannot inherit from A to B. Then you cannot inherit A to form B and then inherit B from A. It cannot happen, right? How are you going to do that? You're going to see the class first, and no. That's not a possible way of achieving such. This is not inheritance. What is this?
Composition.
This is composition.
Isn't all ISA relations are also composition relations?
No. ISA is very different than HAZA. That sentence is good enough for you to fail from this class.
I'm not attend last two lecture, by the way.
That statement is the same as you are failing from this class. We joke between ourselves, sir. He said that isn't all the HAZA relationships also the ISA relationships? No, they are very different. ISA is very different from HAZA. How could this happen? And by the way, this is a very useful UML, very useful design. Very practical. It will work perfectly. It will handle everything about dynamic memory and everything without doing much. And this kind of implementation is going to be right.
So which one has which one? PFRAD has PFRAD backup.
The other way it cannot happen, because inside PFRAD you don't know about PFRAD backup, right? PFRAD cannot know about PFRAD backup, because it is not formed yet, okay? PFRAD backup needs PFRAD to exist so that it can derive from it. Why am I doing this? Yeah.
It provides information about its children.
Well, why would I do such a thing? No. As I said, I am not going to change anything about this PFRAD object, okay, or class. PFRAD does not know that PFRAD backup derives from it. Also, PFRAD doesn't know that PFRAD backup uses one of its object as in composition. I am not going to modify any PFRAD stuff. Okay, let's try to write it. I am sure you are going to like it, or as always, I don't think that you are going to care, but I am going to write it anyway.
List?
I am what?
Is it like linked list, something pointer as a composition?
What is linked list?
Is it storing a composition element as a pointer, or?
No, let me write it. Okay, I'm going to get rid of this, and I'm going to say I have a, how do I write it? PFRAD object, and it is my backup. That's it. So in my private data member part, I am going to keep a PFRAD object. What does that mean? To keep the backup of PFRAD, I will use my PFRAD object. What? How am I gonna do it? Well, let's try to implement this backup function. Let's go to this backup. Where is my backup? Backup is this. No, I don't need those, any of those. Comment them out. So I have what? I have B, right? B is a PFRAD object. I can use this B to keep copy of myself. So what am I gonna do? I can say I can say, what should I do? I can do this thing, bi, guess the value of a I in a loop, right? Like this loop. B is a PFRAD object, right? B is a PFRAD object, so I can do this, but you might say that, well, it is not initialized and its size is 0, etc. Maybe I can do this. Add element. Okay. AI. Good. So I am adding this element to this object B, which is of type PFRAD, one by one. Okay. This is how I do the backup. And this is how I am going to do the, well, restore is exactly the same thing. Did not change at all. So backup is like that, restore is like that. So what did I gain? Why did I do that? Okay, you tell me. Why did I do that? I keep saying that this is a very nice solution, but what is nice about it? I mean, it is almost the same thing, okay? It is almost the same thing. So what is the advantage of it? Let's go to the constructor. So this one will go away, right? This one will go away. And what am I going to write here? Nothing, right?
Yeah.
It's going to be just B, right? No parameter constructor for B. How about this one? What am I going to do? I am going to just initialize B with capacity value. Let me do this indentation thing, and how about this? This one will go away. How about the copy constructor? What am I going to do with the copy constructor? Okay, the question is this. Do I need big 3 for this class now? Do I need big 3? What is funny?
I say yes.
Yeah, I sometimes do that too. I just laugh by myself, yeah.
No, small tree.
What?
You need small tree.
Do I need any tree at all? Do I need big tree? Do I need copy constructor, destructor, assignment operator? What is the rule for the big tree? If you need to make deep copying, yes, you will. Did we need big tree for the day of year class? No. Did we need big tree for a person class that has the name and the TC kimlik numarası or the employee class? No, right? So this is as simple as day of year class, right? Because member-wise copy of PFRAD objects are fine because assignment operator is handled for the PFRAD objects very nicely, no problems. Assignment will work fine because I did that. So I don't need this PFRAD backup destructor. I don't need the assignment operator if I can make this. And I don't need this copy constructor. And in fact, I erased everything? No, okay. That's okay. So this is a very simple class now. And it does exactly the same as what we have done before. It is doing everything dynamically by itself, right? At the beginning of the class construction, this one doesn't know its size, but I set it by calling the base classes constructor, right? And B is capacity value. And so everything is gone. It became a very simple class, very, very simple class, and it works. And why it works? Because I am doing it this way. Okay. Yeah.
If we have PFRAD pointer as a member variable.
If you had a PFRAD pointer as a member, then yes, you have to. Because it's a pointer, then you have to allocate objects, you have to delete them, you have to, when the copy construction, you have to copy them, etc.
So is it all about having a pointer member variable?
Well, I mean, you should be very suspicious whenever you have a pointer in your class. If there is a pointer, then that means that it is pointing to an object. You don't want to copy pointers around. You want to copy whatever you are pointing to. That means deep copying. Deep copying means that you need big 3. Okay? This one doesn't need the deep. Well, this one, I mean, it does the deep copying, but assignment operator of the base class, here, okay, will handle this one. Remember the default meaning of the assignment operator is member-wise copy, right? So member-wise copy will copy this object to the other one, and that assignment works because that member-wise copy is going to use the base classes, either the assignment operator or the copy constructor. Okay, good. Understanding this solution is not that easy without understanding my previous solution from the book, right? Understanding why this solution is a better solution than the other one is not easy. So you need to implement it the difficult way. Then you come to this one, you will say that this is exactly the same as that one. I know how it works. I implemented it. But this one is simple to implement, simple to maintain, and simple to think about. Okay? Simpler things doesn't mean that they are simple actually. I mean, they are complicated under the hood, and it is important to understand why it is a good solution, okay, and why it works, and how can I build on top of it. Without understanding pointers, without understanding dynamic memory, it is not possible to understand why this is a good solution and why it works. Some people say that, okay, I just try stuff, I run the types, different stuff, I compile it, if it compiles it is good, if it doesn't compile I just change it and etc. That's not a good way of writing programs, okay? That's not engineering, that's just trial and error. Well, trial and error is good for learning, but those people are writing their programs like that, okay? They keep writing, okay? They keep writing and until something works. When it works, they just say that, okay, it works 90% of the time, and they don't know how it works, and that their software is not reliable. They think that, okay, I am going to change jobs in every 12 months anyway, so who is going to know it, right? So that's not how you should do stuff. When you write stuff, you should know how it works. When you write stuff, it should always work. Good. If there are no questions, then I will continue from the book side. Oh, okay. One more thing for you. How about this? Instead of writing a PFRAD object by that, okay, I will have a PFRAD vector. Every time I take a backup, okay, I don't erase the previous backup, but I put on top of the previous backup. Understand? I keep taking new backups every time. I don't erase my previous backup. So I can take a backup, then another backup, another backup. When I restore it, I restore from the top of the vector, then another one, then another one. Now maybe I should make this a stack. Okay? So you are pushing on top of the stack, your last vector, and you are popping from the top of the stack. It is as simple as typing a few letters in here, right? Going from that solution to this solution. It's a very complicated class now. It can do very complicated stuff. But writing this is a simple line of code. This is possible because of code reuse, right? I have implemented PFRAD in a very nice way. It's a reusable class, very clean interface. It is very robust. It doesn't fail at all. I did test it thoroughly. Now I can use it in a very useful way for many classes. That's what the object-oriented programming is about. Reuse the previously developed code, and your previously developed code will be in terms of classes, and classes are easy to reuse. Good. Okay, let me go back to the slides and let me continue from there. Okay, so the book says, functions not inherited, but as I said before, everything is inherited. Everything is inherited. But some of the functions, they don't become your functions exactly. You need to define them. For example, constructors, they are inherited, okay, but they don't become your constructors because you're a new class. You need to write your constructors and you need to call the base classes constructors. Destructors are not, they don't become your destructors. They are called automatically. Again, copy constructors and assignment operators. They are inherited, but they don't become your copy constructors or the assignment operators. Okay? For the last case where I did this one, remember this one? Okay? I made a PFRAD object, my private. Okay? For this one, I didn't need the big three. That's why I said that default copy constructor, default assignment, and default destructor is fine with me. Okay? So I didn't have to implement them. I didn't implement them. Good. Talked about those. Assignment operators and copy constructors. Okay. Well, I wouldn't say they are not inherited. Again, let me put this in quote. They are inherited, but they don't become our copy constructors and assignment operators. Okay, and usually I do this. I call the base classes assignment operator. Okay. Good. And copy constructor, call the base classes copy constructors. We do that too. And destructors are like that. Okay, I think I have a. So base class has a constructor and a destructor. Right class has the constructor and destructor. You understand the code, right? This is just the base class. This is the derived class. B means base. DE means derived. Okay. So I have simple cout statements in it. It says B constructor, B destructor, DE constructor, DE destructor. Okay. So I think I am going to test this thing. If I make a B object and if I make a DE object, what happens? So when I make a B object, it calls the B's constructor, right? But when I make a D object, it makes first a B's constructor. First I build a B object, then on top of it there is a D object, right? When I hit this line, okay, I am going to kill both this B object and the D object. The first one will die as the D object, okay? First one will die the D object. D object inside will kill the D object first, then the B object. Then I am going to kill this B object here. So write this kind of simple test code and test it yourself. See the order of constructor calling and destructor calling. Okay, yes.
Why D first? We said.
Which one? Destructor or constructor?
We said base class die first.
Yeah, that's what it says.
B class isn't main.
Well, yeah, D dies first, and it's just the opposite of the. See, B is constructed, on top of it D is constructed, D is destructed, then B is destructed. Just the opposite of the construction order. Okay? Good. Let's continue. Destructor calling order we just opposite of how the constructors are called. Okay, test this too. Is a versus has a relationship is very, very different. Inheritance, and both of them are very nice ways of achieving code reuse. Okay, very nice ways of achieving code reuse, and we will use them very, very often. Okay, and we did this already with the employee, hourly employee, and etc. with the inheritance. Has a relationship is good too, but its meaning is different. And sometimes it is possible to use both as a relationship and has a relationship. It is easy to get confused between them. Always ask this question in real world: is an employee, is an hourly employee an employee? The answer is yes. Is a PFRAD backup object a PFRAD object? Yes. Okay. But has a is a different thing. Can I use this object instance of this object in this class inside another class? The answer depends on you. Okay. Remember what we said about about this one. Why do we write public here? Okay, if you like, you can write private or protected at this position. So public, write private or protected. Okay, so what does that mean? Let's look at that. Okay, this is called public inheritance. The other one is private and protected inheritance. Okay, if you do protected inheritance, the base classes, public members, data members, or the function members become your protected data members or function members. Okay, so the base classes, public members become your protected members. If you do the private inheritance, very similar. Okay, base classes, public will become your private. Okay, that's the meaning of it. Protected inheritance and private inheritance, and I had never used it. Okay, both of them, and these are not ways of achieving is a relationship, because if base classes, for this one, if base class is public, for example, add element becomes your private, then you are not a PFRAD object anymore, right? Because add element doesn't work for you for the customers. So it's not an is a relationship. Nobody uses them. I don't know why they put it in there. I don't know. I mean, sometimes people think that this would be a very useful thing, but it doesn't become very useful. Nobody uses them. And if, in fact, when you start using it, it starts becoming a problem. So it is just because there. That's why we are talking about. I mean, I wouldn't talk about it, but people ask lots of questions about this. What is protected inheritance, private inheritance? So that's the meaning. And your moral of the story of this slide is, know about this, but don't use them. Okay, good. So multiple inheritance is more important than that one. Let's say I have such a nice hierarchy. I have a person class here. Okay. Inside the person class, as a private data member, I have name. I have a student class derived from person. I have employee derived from person too. Okay. Both of them are persons. There is an is a relationship. There is an is a relationship, right? Students would have their GPAs. Students would have their GPAs. on top of the name, and their ceteris getters, of course. Employees will have their salaries. Okay, up to now it's a very nice hierarchy. How about this? I like to have a student employee class. Student employee class. The student employee class will have both GPA and the salary and the name. Okay, so multiple inheritance makes sense. It's very useful, but in terms of compiler, internal workings of the compiler, it is problematic. Why? Because there is an is-a relationship from this path, there is another is-a relationship from this path. This student employee will have two name data members in it. One is inherited from this path, the other one is inherited from this path. Okay, somebody has to solve it. You need to tell the compiler that you are using multiple inheritance that will share the same data, etc. That's called virtual inheritance. I am not going to talk about them. I like to, but the book doesn't talk about them, and I'm not going to talk about it. That's why some languages, like such as Java says that, well, multiple inheritance is nice, but I am not going to allow it. That makes the compiler very complicated. Somebody has to implement the compiler, right? Compiler. I hope you realize that compiler is a piece of software, right? Are you guys realizing it? If it's software, then somebody is writing it, right? Writing compiler is as difficult as rocket science. It's very difficult to write compiler programs. That's why it took them maybe 20, 30 years to write this GCC thing, right? Every time they change it, and like a few years ago, maybe 10 years ago, they have formally proved that they had a formal proof that GCC really works and etc. They keep working on it because they are very critical piece of software, but they are software. Somebody has to implement this software. Somebody has to maintain it. Java people said that let's get rid of multiple inheritance. It makes the compiler very complicated to write and maintain and etc. So they found other solutions for this one. Okay, they found other solutions for this one. But in C++, it is possible. All you're going to say is, I have a new class. I have two public base classes for it, base 1 and base 2. Okay? Remember, we used to say public base class. Now, I have two base classes. Okay? Ambiguity, loss of, and this the book claims. For example, when you say, get person name, which path are you going to get it from, and etc. And the book says that dangerous undertaking, some believe should never be used, certainly should only be used by experienced programmers. I don't agree with this. It is not dangerous. Of course, you should be careful about it, yes. And I don't think that should only be used by experienced programmers. Well, if it is the case, then I hereby declare you as experienced programmers. You can use multiple inheritance whenever needed. Okay. Good. I don't have any examples for the. Well, the alternative way would be a person and employee separately. And how would you solve this problem? There is in the person. Okay. Well, I'm not going to go into that one. Okay, I'm not going to go into that one. So whenever needed, you just use it and look up the problems and how to solve them yourself. Okay, any questions so far? Okay, if there are no questions, let's take some break. After the break, we will continue.
Ne? Sahneye buldum diye kızdım.
Oo, yıllar önce. İşte yıllar önce ben 8'i 5 geçeye göre yemek yedim. O zaman yoktu. Ben 8'i 5 geçeye göre yıllar önce metingde gideceğim bana da olur. Bu sene? Bu sene 8'i 5 geçe var mı ya? 35 geçe. 35 geçe. Onu karıştırmıştım. Ondan önce ben dedim kanka ben 8'i 5 geçeye göre yemek yedim. Yavaş yavaş. Tamam. Şu bir bak. Aa, geçen hafta böyle değil mi? Hayır, şey böyle. Ben de soğudu, 2 günde soğumuş.
Ekim ayında full yağmur yağdı.
Genç başlı yani. Messi Ronaldo finalde almıştı.
Soğuk sıcak kapatmayı aşağı.
Yok fark etmez.
Ahmet diyorlar ki zaman yapmıyor.
Okay, new chapter. Chapter number 15, polymorphism and virtual functions. Polymorphism and virtual functions. Where did I put my other notes? Polymorphism. Okay, remember when we started talking about inheritance at the beginning of the chapter? I showed you this one. We said that object-oriented programming fundamentals, encapsulation and abstraction. Abstraction is at the top. This is the most general rule, not only for the object-oriented programming, but for all types of programming paradigms. Abstraction is at the top. Just abstract away the details. Talk about the concepts, not the details, not the implementation. Then the encapsulation, we talked about it. Put together your data and the functions in a capsule and call them classes, and we call this encapsulation. Then we talked about inheritance. Inheritance is extending or deriving from your base classes to give more meanings to them, to write more specific classes. Now we are going to look at this polymorphism. The name polymorphism, poly means many, morph means face, many faces. It kind of translates to English like that. Çok yüzlülük, sometimes they call it in Turkish like that, çok yüzlülük. Well, the name doesn't explain much, okay? The name doesn't explain much. That's why we are going to look at the concept itself, okay? Again, this is about writing reusable code, okay? Writing reusable code. Remember inheritance? Inheritance says that, okay, write classes in the most general case so that they can become a base class for some other classes. Later, write more specific classes. Write the person class first, Okay, maybe a person class doesn't make much sense, or employee class doesn't make much sense. Why? Because I don't know how to pay an employee. Okay, I need to know how it works by hour, by commission, by salary, and etc. No, we say that write the employee class first. Maybe it doesn't make much sense, but when you derive from employee, like the hourly employee or the salaried employee, then it will make sense. So that's the idea of inheritance. Polymorphism takes this idea, okay, says that I am going to teach you, I am going to tell you one way of writing these base classes so that they are much more reusable than than otherwise. Okay, that's what we are going to do today, and we are going to write base classes such that it doesn't make much sense by themselves, but they will be very meaningful in terms of a base class in an hierarchy. So polymorphism is today's topic. Okay, let's go to polymorphism and virtual functions, the book. Okay, so again, I think I will give you one or two keywords, one or two new. What did I introduce in the inheritance chapter in terms of new C++ syntax? It's just that public base class thing, right? Other than that, did I tell you anything new in terms of syntax? No, right? What? Protected, yeah. Protected keyword. And in fact, I mean, we can live without the protected keyword if we use a public interface. I mean, this is what's going to happen. I mean, when we go along our journey about object-oriented programming, I am going to introduce less and less new syntax mechanisms, but more and more deeper ideas about object-oriented programming. That's what happens. Okay, so we keep using the same keywords, we keep using the same techniques, but same syntax techniques, but semantic-wise, the meaning-wise, it's going to be very deep. Okay, sometimes difficult to understand why it is happening. So with the polymorphism, there is this virtual keyword I'm going to show you. With that keyword, I'm going to introduce you this idea of late binding. It will be a different world, okay, and it will take us some time to understand how it works and sometimes to understand why we are using it. But once you understand it, you are going to see that out of all the object-oriented programming techniques, okay, polymorphism is the maybe most widely used one. Okay, people don't realize it, but it is most widely used one. And without understanding the function pointers, it is difficult to understand the polymorphism itself. That's why to be able to be a good computer engineer or programmer even, you need to know C programming language and pointers actually. Okay, let's go to polymorphism. The book gives this example, okay. The book gives this example of shapes. Let's say we have a shape hierarchy. Very classical example of hierarchy is shape. I have a class shape, two-dimensional shape, okay? So what do I have? Tell me what kind of functions would I have for a shape class? Give me the area of a shape, right? Give me the perimeter of the shape, alan ve çevresi. That's it. Two functions. What else? What?
Ring functions or getter functions.
Getter for what?
For area.
Well, this is already an area, right? It's just getter for the area.
As a property of shape, right?
What?
Function of property of shapes.
Maybe
For example, the inner degree, sum of inner degree.
Yeah, maybe you can say inner degree. What's an inner degree? Inner degree is
364 square. 184 triangle.
how about, yeah, well, you can say that, right? I mean, how about the inner degree for this ellipse or circle? It's going to return what? Maybe throw and terminate? Yeah, could be. I don't know. Well, I mean, I cannot say, the number of sides maybe. How many sides do you have? Number of edges, number of corners. If it is convex or concave and that kind of stuff, maybe. Those kind of stuff, but how about the data members? I mean, I cannot, I mean, if it's a circle, for the data members, I know. The radius is a very nice data member for the circle. For a rectangle, the length and the height and etc. I cannot write those, but I have this area and the perimeter. By the way, how do you calculate an area of a shape? I usually can't, right? I mean, if it's a rectangle, I can do that. If it's a triangle, I can do that. Circle, ellipse, and etc. I can do that, but I don't know the shape itself. I need this hierarchy: the circle, rectangle, maybe from rectangle to square, and there is a polygon, right? So this is the shape hierarchy. This is the shape hierarchy. When it comes to writing this shape class, well, the shape class is nice, but I cannot implement how do you implement the area? How do you calculate the area of a shape? I can't, but I can do this maybe, okay? This is my shape class. It says double area const, double perimeter const. I don't know how to implement area or the perimeter, right? How about this one is larger? Boolean is larger. I am going to compare myself with the given shape, and if I am larger than in terms of area, if I am larger than the other shape, I am going to return true, otherwise I am going to return false, right? So I can do that. Let's look at this circle thing. Circle says that, okay, I am a shape actually. I am a shape, right? I am a shape. Since I am a shape, I will derive from it. On top of the shape, okay, I will put this double R, the radius. Since I know what kind of shape now I am, I can do this area, I can do this perimeter. Area is pi times R times R, and perimeter is 2 times pi times R, right? And by the way, this is my constructor. The constructor, the default argument is 1.0. It doesn't call the base classes constructor. Default constructor is fine, I guess. Maybe I forget to do it. Maybe there is nothing to do that, right? Okay. So this whole circle thing is implemented. Okay. This whole circle thing is implemented. I guess I didn't need any circle CPP because it was implemented. I'm going to do the same thing for the rectangle H, or ellipse H, or polygon H, and etc. Okay, let's go to this shape thing again. Shape class. The thing that I can implement here is larger maybe, and I'm going to do this. Inside shape.cpp, I cannot implement area. I cannot implement perimeter, but I can implement is larger. So this is what I'm going to do. Call my area and call the other area. If my area is larger than the other area, return true, otherwise return false. Okay, this is very nice. I can implement it. This is generic code. I don't know, I mean, remember the rule? Shape doesn't know. Shape doesn't know that somebody is going to derive from it. Okay, this is how I do the shape class implementation. It doesn't know. But I can write this code. It's a very small piece of code, very generic code. It will work for any kind of shape, including circles and etc. and etc. Let's look at this one. So I did this. Include shape H, circle H, rectangle H. There is a circle and there is a rectangle C1 and R1. and I call this one, is C1 larger than R1, it's going to return either true or false. I am going to print it out. Okay? I am going to print it out. So let's look at this, how this is larger is going to work, right? Is larger is this code, and it is written by myself when I have implemented this part of the hierarchy, the shape hierarchy, right? Okay? So let's see how the compiler thinks. Okay? If you are the compiler, what kind of code would you produce? I mean, how many, looking at this whole thing, okay? Looking at this whole thing, let's say I have implemented all of them. 1, 2, 3, 4, 5, okay? There are 5 classes. How many area functions are there? 4 area functions, right? Because I cannot implement it for the shape. I don't know how to implement it. Okay? 4 area functions. When the compiler compiles this code, which function does the compiler call for this area or this area?
For its sub class types. Yeah.
Even I didn't hear you.
It should call its subist sub class.
But it didn't know which one is the subist, because when I write this, when I compile this shape.cpp, it doesn't know anything about hierarchy. Okay? How does the compiler know which shape to call? Yes.
Since we are inheriting from shape class for each object,
Yeah.
Each object has shape class, and we are modifying the area function. So whenever we call this area,
Yeah.
we will use the area function for that specific shape.
Well, yeah, you feel that it should work that way, but this shape.h and shape.cpp, how do you compile it? You say gcc minus c shape.cpp, right? That's how you compile it, right? When you compile it, this one doesn't know anything about those classes. Those classes, they don't have to exist. Okay? When you compile this code, there is no mention of circle.cpp, circle.h, rectangle.cpp, rectangle.h, and etc. Okay? Unfortunately, when you compile this one, okay, when you compile this one, it will try to call this area and the perimeter here, the shape area and shape perimeter. You have to write it somehow, otherwise, right, your code wouldn't compile. I mean, if you don't have any implementations for the area and perimeter, this will not compile, right? When you call this, it will say that, okay, I cannot call anything, right? It will not compile. Unfortunately, it just calls this one and this one. Probably those will return -1 or something like that. So this is not what you want actually. I mean, this doesn't turn out to be the nice little generic code that will work for all kinds of classes. Okay, this is not working that way. That's the problem. The problem is the compiler has to make this decision during compile time. During compile time, compile says that what is the type of O? It is shape. What is the type of this? It is shape. So I am going to call the shape area and shape area. Okay, so that's the compiler's decision. It is decided during the compile time. These are called early decisions, early binding. Okay, early binding, and okay, early binding is decision during the compile time. During the compile time, compiler says that, okay, you are going to call this one and this one and this one. Everything is written. that way. And up to now, all we did is early binding, okay? Compiler knows which function to call during the compilation time. That's why when it produces code, okay, it says that call this one and call that one and call that one. Remember what we did with our, see, let me go to my compiler explorer. Did I erase that thing? Okay, good. Why did this compilation fail? Do you guys remember what I was doing? Oh, okay, because the signatures are the same. Okay, so. Okay, let me do this G4 and integer G, integer K, return, just a simple thing to show you. Okay, so this is my code for Z1FI, F function. F function in somewhere calls Z1GI, it calls G function, and G function is run and it returns something. And G function can call itself an infinite recursion. So G function is calling itself, right? That is an infinite. So a compiler knows which function to call. These are all decided during the compilation, and this is my assembly code. Everything is very well known, and this is what I need to do, okay? Compiler needs to know which function to call, but doesn't work in our case like that, okay? I say that I am going to send you a shape, another shape, and compare them. C1 is a shape, R1 is a shape, okay? This function will work, but this function will call the area function of the base class shape, right? Area function of the base class shape, and unfortunately, I will have to implement them like this. What is the area of a shape? Return. Unfortunately, I have to do this, right? Not very meaningful thing. Return minus 1.0. So that the caller would know that I am not returning a very meaningful thing. So even though I am calling this is larger with two circle and rectangle, this is larger since it is compiled with the shape class. It calls these two stupid functions, okay? It calls this area -1, -1. This will return false, I guess. This will return false. So it works all wrong. So what I want is actually, I like this, okay, since this, this is a circle and O is a rectangle. I like this to call circles area. I like this to call the rectangles area. Whatever they are, they will return to me and I will say this one is less than or greater than that one. That's what I want to. What?
Why we implement is larger member function in base class? Just
Because it is more suitable for them. Otherwise, I have to write is larger function for all the classes, right? Whenever I add a new class, I need to modify this is larger, right? I like my is larger to be generic. I like my is larger to work for any kind of shape extended class, right? So it is the most generic way of writing stuff. That would be the most reusable one, right? So they have noticed that, and they said that, okay, I am going to introduce this idea of virtual functions. Virtual is a keyword. Virtual is a C++ keyword, okay? It says that if you are going to make a function call for a virtual function, okay, virtual function, then you can delay your decision until the runtime, okay? So when you are calling a virtual function like this area or perimeter, You are going to make the decision during the runtime depending on the type of this pointer and depending on the type of this object, okay? Well, you might say that, well, object is of type shape, right? Well, it is of type shape, but maybe it is real type is a class derived from shape such as rectangle or the circle or ellipse or polygon, right? We don't know. So that's why the compiler will delay this decision until the runtime. During the runtime, when I call this function, it will inspect this reference. Okay, it will inspect this reference. If it's a reference to a rectangle, it will call the rectangles area. If it's a reference for circle, it will call the circles area. Okay, and this is called late binding. Decision on which function to call is made during the runtime. Okay, that's called late binding. We never did this before. We always did the early binding. Late binding means that you bind the link between this code and which function to call during the runtime.
Can't compiler decide this in compile time?
What?
Can't compiler decide this in compile time?
No. Why? Because how do you know that what kind of parameters did you call this is larger on, right? I can call this R1 dot is larger C1. I can call R1 dot is larger R1, right? It changes during the remember, I have written this code 20 years ago and it is fixed. Today I am deriving a new class out of this shape and I am calling is larger. Is larger is compiled 20 years ago. Okay? But I like this code to work with my new class too. I like this code to call my new area that I have written today. Okay? So that's called polymorphism. Why is this polymorphism? Because I don't know the meaning of all that area, okay, all that area. During the compile time, its meaning changes. What's going on? Okay. So it changes its shape from call to call. That's why it is poly. It's many shapes, many faces. I don't know the meaning of this piece of code, not until the runtime. And it changes its meaning depending on this object. Okay? So I cannot produce a code like this anymore. The meaning of GK is always G, always call this one. No, it doesn't happen anymore. It has to be different. So let me try to write this in an example. Class A, okay, class A, and inside the class A, I will have, let's say, in the public section, function F, and let's say it is void. Okay, it compiles and it says, no, okay, no assembly to display because I didn't use it. Okay, in a function G, I am going to make an object of A and A dot F. Okay. Well, let me implement this. Good. Okay, where is my G? My function G? Where is, okay, this is G, right? This is calling this one. Okay? This is, let me make this func so that you can read it better. Inside this function G, I think, okay. Inside this function g, I am calling this function, right? By the way, see how it works? The compiler produces your assembly code in a way that all of your member functions are actually global functions. Their names are just different. It says that I have a function named func. It doesn't take anything void, but it is part of this class A, right? A4. I can say the class ABC, and this one is class ABC. See, the name of this function is ABC for function, etc. So it is just combining the name and the function itself to make a global function. That's how it is compiled and how it is done. In the assembly language, there is no polymorphism, there is no object-oriented programming. It's all global functions. Okay, so this is the function of the class A, and this is how I am calling it. As soon as I make this virtual, okay, as soon as I make this virtual, and let me make this, okay, it looks like inside this function, it is still calling it during the compile time. It says that I am going to do that. To achieve this polymorphism, you need to follow some rules. I can do this, okay, A, B, C, D, and it is a, let's say, make this a reference, and A, okay, and without references it doesn't happen. Okay, did it compile? Did I do that? Okay, let's take this out. Doesn't compile and do this. I am going to force it to, no, still compiler is behaving smart. Say that I know what the type of it like now. Okay, let me do it this way. Okay, integer void k, and I'm going to take an ABC object like a reference object and do this, and I am going to call O dot function. Okay, so this one, as you see this in this function, let me get rid of this way so that that wouldn't confuse us. Okay, so this function f, let me make this, okay, f1. This function f1, okay, as you see inside f1, you don't see any call something calls. As soon as I get rid of this virtual, so it says that call this function. See, when I put virtual in it, it doesn't produce any code to call something, okay? It says that do some calculations and call something, but I don't know what that call is, okay? So it is not making any decisions. It is not making any decisions on which function to call during the compile time. And if I take this out, then it's just a simple function call. Well, all I am saying is that when you put this keyword virtual here, your code becomes more complicated. Your code becomes, I am going to wait until the runtime. If somebody makes this call, okay, when I am executing that call, when I'm executing that call, I will make the decision of this area. This area could be a circle area, rectangle area, ellipsoid area, whatever it is. But I will make that decision during the runtime because compile time I can't do that. If I am adding another one here, cout r1 dot is larger r1, okay. The meaning of area and this area will be different than the meaning of the area for this line. Every time I make this call is larger, the meanings of these two calls will be different. That's why it is called polymorphism. That's why it has to be decided during the runtime. Yes?
Can I offer any other than this new method for deciding this in compile time?
Sure.
If they implement virtual instead of putting virtual.
Abdurrahman is offering another way of achieving this. I'm translating it for you because he's not capable of talking loud. Yeah.
Instead of putting virtual keyboard in front of the function, member function, if they put it in front of const shape, virtual const shape, then compiler can decide what is the
virtual const shape. What?
If they implement it, compiler in that way, is larger.
Oh, you are suggesting that they
can do it in compile time side.
You are making a new suggestion for a modification for C++.
Yes. So they can decide what is the subs shape of.
Subs shape, yeah, that's a good.
Shape.
We shouldn't forget about this. Okay, thank you for suggestions. We will take that into consideration for C++ 25. Okay. Abdurrahman has spoken. Yeah. Okay, so that's the whole thing. You might say that. So what is the big fuss about this? Why are we talking about this very simple thing? And you are not even sure why this is so useful. Well, I don't have enough time to talk about it. Tomorrow morning we will talk about it, why it is useful, and tomorrow morning we will say why this is one of the most widely used features of object-oriented programming. That's it for today.
Hocam yani mantıklı.